In Module 4, we'll see how to price an option, a European option, on a non-dividend stock where the expiry is 2 binomial steps from today. In the prior module, we looked at binomial options that expired in 1 step. We'll see how to adapt that procedure if there are 2 steps instead of 1. So here's an example, all the same parameters from the earlier. You may remember the prices in the prior module. $41 went to $59 and $32 using U and D based on these parameters. We have an H of 1, an R of 0.08. So what does that mean? If you, in this case, U is equal to E delta 0, so it's just RH plus sigma 0.3 square root of H. So this is E to the 0.38. D is equal to, correspondingly, would be 0.08 minus 0.3. It would be E to the minus 0.22. Okay, so that's how I mentioned in the earlier module, we would later see where the 59.95 and the 32.90 came from. They came from these formulas involving R delta and sigma, as well as H. This is a 1 period, H is 1. And if we just applied the same U, this is equal to SU squared, this is equal to SU times D, and this is equal to SD squared. So we now have a 2-year lattice, and we'll assume that we want to price a 2-year call option with a strike of 40. You can see the payoffs in the lattice right here. These are apparent. When the stock is worth 47 at 87 at expiry, its exercise value is 47 and change. When the stock is worth 48.11, its exercise is 8.11. And when the stock is worth 26, the exercise of the call is worth 0. We'll now see how to go from these expiry values to the values we see earlier in the lattice. Namely, we have a value of 23.029 and 3 here. And then finally we get a value of $10.74 at time 0. Let's see how we, in fact, get those prices. Well, first of all, notice that as we saw in the earlier module, SUD and SDU are greater than 41. So this is a case where the risk-free rate is greater than delta. Risk-free rate R is 8%, delta is 0, and so we see that this is an example of a convex price lattice where the value of the stock here, after going up and down or down and up, the value is greater than it was to start. Also, we note that in this particular tree, SUD and SDU are the same. In other words, if we go up and down, we end up at the same stock price as if we go down and up. This is called a recombining tree. We will see other trees, in particular in a chapter on interest rate models, where oftentimes the tree does not recombine, that SDU and SUD will be different, called a non-recombining tree. So now let's look at the calculations of options. We already saw the expiry values. That's simply by implementing the exercise function at time 2 years. Now let's look at the price of the option earlier. Well, if we wanted the stock price at when the option price when the stock is at $59, we can use the mechanics of the earlier module. And that's because If we just look at this section of the lattice, it's a one-period binomial lattice. It's a one-period binomial lattice in which we know the value of the option, 47 and 8, one period away. We can calculate the value 23 using the mechanics of the earlier section. And that's what's done on the slide we were just looking at. Namely, that we have an expiry value of 47 and 8. This is the present value, the expected present value. This is the formula for P star, the risk-neutral probability, and this is the formula for 1 minus P star. You recall it's e to the RH with the delta adjustment minus D over U minus D. And when you do this, you get the $23. We can also look when the stock price is at $32.90. Again, it's really just a one-period lattice. Using the same formula, we get the $3.18. We now have both option prices at time 1 year. And that means we can price the option at time 0 using, again, that equation 10.3, and we come up with the final value of 10,737. We could also calculate the replicating portfolios. You'll remember from that two-period lattice we were looking at, it also showed the delta at each node on the lattice as well as the B value. And in general, delta and B will change at each node on the lattice. This is a point I made in an earlier module, that unlike replication for a forward contract, when you replicate an option, the portfolio must be rebalanced every period. And the rebalancing involves changing delta and changing B. So here's an example of calculating the delta and the B associated with the stock price being $59.95. And these are formulas from the earlier module. You can see them here notationally and then with the numerical values from the lattice. And once you have those, the value of the option using that replicating portfolio is of course the same as the value of the option using formula 10.3, which is often referred to as an expected present value formula. Namely, it's an expected formula because we use P star and 1 minus P star, and it's a present value formula because we're discounting at the risk-free rate.